hope you enjoy your pumpkin cupcakes with chocolate frosting on them. And we're going to be looking at stacking up these different trig functions, including the sine graph and the cosine graph, and then manipulating them by adjusting the different amplitudes and different periods. So at this point, what we know is that we are able to graph the 6 basic trig functions: the sine graph, the cosine graph, the tangent, cotangent, and the secant and cosecant graphs. Now we're just going to focus on 2 graphs, which is the sine and cosine graph, and look at the amplitudes and periods of them. We're going to use your graphing calculators today to develop some of these concepts. So we're going to first graph the basic sine graph, and notice on this that I have nothing, no plots turned on. I have nothing in the y equals, and for the mode right now, I'm talking about radian mode. Then what I'm going to do is go to the y equals and put in the sine x. And I'm going to think about what happens when I do this before I hit the graph button. When I multiply by 2 to the sine graph, what that means is it's taking every y and multiplying it by 2. And so a 1 becomes a 2, a 1/2 becomes a 1, a -1 becomes -2, takes your y's and stretches them out. And I could also at the same time do a -3 times the sine of x. And just to distinguish between the two, I can go all the way over to the left side, push enter, and it'll give me a thicker line for that -3 times the sine of x. So when I graph this, I should kind of visualize it before it actually happens. I'm going to think this one's going to be twice the stretching, and this one will be -3 times the stretching. The negative means that the positive y becomes negative, and the negative y becomes positive. When you go ahead and graph that, there's your basic one, your y equals sine x, and this is going to be y equals 2 times the sine x, and then there's your y equals -3 times the sine x. Thinking about the amplitude of each of these, the first graph had an amplitude of 1, the second one had an amplitude of 2, the third one has an amplitude of 3. Amplitude is always positive. It's the distance between the middle axis, called the sinusoidal axis, and the minimum point or the maximum point. So on your notes, you're going to see that when you go through here, your A represents your amplitude. So the amplitude is really equal to the absolute value of A. Whatever number is before that you're multiplying, the absolute value of it is your amplitude for the sine and cosine. Then we're going to look at the period. And the period is a little bit different in that it's a little bit less intuitive when you graph it. And so when I go to here, again, what I'm going to do is, I think I'll do the cosine graph this time. And what I want to do is graph the cosine of 2x and see what happens there. And I want to think about it before I graph it again. If I multiply 2 times x, what that means is your x's are going to go through the period twice as fast. It's going to speed up through your x's, which means that the period is going to be half the distance. In other words, through a certain amount of time, it's going to have 2 periods instead of 1 period if you multiply by 2. If you multiply by 5, there would be 5 periods, 5 cycles through that period instead of 1. If you multiply by 10, there would be 10 cycles through that period instead of 1. So I should be thinking there are going to be twice as many cycles in a specific period as I graph this. And when you see that cosine graph, which starts at 0 and starts at 1 and goes down, the second one goes twice as fast because you're multiplying it by 2. However, if I were to go back here and say, well, what about if I inserted a point? 0.2x. What is going to be the new period? Instead of a 1, it's a 0.2. 0.2 is going to mean it's going to go slower through that same amount, and slower by a factor of 0.2. But what does that really mean, slower by a factor of 0.2? Well, graphing, you're going to see that that's really a slow-moving graph compared to the first one. So the question really is on this, well, all right, I know that the period of cosine 2x was pi, right? Cosine of x is 2 pi. Cosine of 2x was just pi because it moved twice as fast. But the period of 0.2 times x graph would be 0.2, and how do I get my period then? What I have to do is I have to take my 2 pi and divide it by 0.2. In other words, if I had a cosine 2x, I take the 2 pi and divide it by 2, and I get my period is pi. If I take 0.2, I'd take 2 pi divided by 0.2. Well, what does that equal? Let's see. 2 pi divided by 0.2 is the same thing as 2 pi divided by 2 over 10. Same thing as 2 pi divided by 1 over 5, multiplying by the reciprocal, and you're going to end up with a period of 10 pi. This information where you're getting your period by doing this math is important because we want to be able to know what my period is before I go ahead and graph what I need to graph. It's going to help me with the setup. And when things get, these are simple so far, but when they get complicated, you're going to want to have a system in getting information. In your notes, you'll see that you have this general form, and then according to what numbers you put in there, you can get your different amplitude, you can get your period. If A is negative, that means it's going to be a reflection about the x-axis. And if you're adding a k, it's like adding a k to your y. You're going to go up or you're going to go down. You're going to shift the whole thing up, whole thing down. Let's go, just another reminder, no amplitude exists for secant, cosecant, tangent, or cotangent because there is no maximum value. Reflecting about the x-axis. Graph y equals cosine x, and y equals negative cosine x, and y equals negative cosine x plus 3. All right, we're just going to do this based on what we know from the cosine graph. So the first thing I'm going to do from the cosine graph off of memory, I know it goes 2 pi units. And you're going to put in a 1, negative 1. And again, the way that I'm going to do this is put points on it and then sketch in the points or connect the points after you're done. Cosine goes from 1 down. So just a little quick sketch over there to remind me what it looks like. So now I know it's just going to go from 1 and go down. And then after you do that, you're going to draw that in. Hope everyone's enjoying your cupcakes, and if you're listening to this, come and see me and I'll get you a cupcake. So let's go back to here and notice that I want to reflect down, and I'm going to, because of the negative cosine x, so that means simply I'm going to just take my dots and reflect it about the x-axis. Just focusing on those dots, and then I want to connect the dots. I'm not making tables, I'm adjusting the y equals cosine x. Then it says, what about y equals negative cosine x plus 3? I'm shifting the green line up 3 units, like this. So you could shift it up 3 units and then say, okay, well, that's now going to be, let's see, plus 3 would be 2, and this would be plus 3, which would be 4. So I could make new axes like 2 and 4. It's not going to be the same. I'm going to have a middle line here. And so I could then put in points. I'm looking at the greenie. And I'm going to connect those, and that would be my y equals negative cosine x plus 3. That's one way to graph that. Another way to graph that I will allow in this class is that if you notice what these new points are, the min on the max, then you can adjust them on this scale and just call it good in terms of that graph. So for example, this would be one way to do it. The second way to do it is to say, I want this to be 2, and I want this to be 4, and now my green graph is hitting the 2 and the 4 in that way instead of negative 1 and 1. But if you do it this way, where you're adjusting these numbers by writing a number next to them, you need to make it very clear to me that you did that. You need to put a new number in, circle it, and like point to what you're looking at, which graph. So it's just got to be very clear. If you don't want to do that, just translate it up like I did initially if that confuses you. But you can pick either method, of course. Let's go to this graph, y equals 1/2 cosine x. Well, often what I will do is I will try to find out what is my period, 2 pi divided by this b here, and the b is really equal to 1. There's a hidden 1 there. And then the second part is what's the amplitude? The amplitude is absolute value of a, which is 1/2. But next what I want you to do, which is not written, I don't think, in your papers, is to find something called units. And so units are going to be really important as we go forward. So you're going to want to put this in a box and star it. And the units are going to be your period divided by 4. In other words, in this particular problem, it's 2 pi divided by 4, which is pi over 2. Boxes, make it real obvious that this is what you want to do. Again, I'm doing things that are different than the book. We're not making tables, we're making adjustments. Let's go through and write down what we're looking at here. So this means that I'm talking about pi over 2, pi, 3 pi over 2, and 2 pi. I'm going up by each unit of pi over 2. And I do it 4 times because that's going to be one complete cycle as I draw this. also know the amplitude is 1/2, so I know I'm going from positive 1/2 to negative 1/2. The framework is done at this point. I put down my 4 points. I don't want anything in between there. And I put down my max, my min points. Now what I want to do is go ahead and put in my points. So I'm talking about a positive cosine. Again, I like to make a little drawing here to remind me what positive cosine looks like. Starts at 1, goes down. That means this is going to start up high and go down. And just fill in your high, mediums, and lows. Then once you get all those ingredients all put down into a nice bowl, you mix it up, and then you can make something interesting, like a beautiful graph here, just like you're connecting the dots or making cupcakes. There we go. Any questions on that? Let's go to this one. Number 38. And what we're going to do here is graph y equals 3 cosine 1/2x. Notice it doesn't say 1 complete cycle. It says between certain points in the domain. So it's sprinkling a little bit of more confusion into the problem. So let's go and get the data first. And the data is going to be, well, the amplitude. Amplitude is the absolute value of 1/2, which equals 1/2. The period is going to be 2 pi divided by my b, which is 1/2. That equals 4 pi. And then my units. And the units are going to be my period divided by 4, which equals pi. Seems suitable that this would be actually, was I mistaken? Oh, yeah, thank you. Appreciate it. Amplitude is 3. So, at this point, we're going to go ahead and put my click marks in, or my units in, so that's going to be pi, 2 pi, 3 pi, 4 pi, that's all of these units. But I also have to pay attention to